Good morning, everyone. This is ZFF 40. Just showing you what I come to the conclusion of. I've been playing with my cell. You notice it's wired in a 3 and 5 configuration, which is typically extremely inefficient. In other words, this thing could be getting hot really quick under normal circumstances. If this was getting fed with the brute force straight DC, it would be getting hot. But what I did was I took my I don't know if I can point in it. I set my current limiting, basically backed out the duty cycle all the way out, so wasn't interfering. I adjusted my current limiting, so I had 22 amps on the amp meter. And then what I ended up doing after that is I backed down on my duty cycle until my plate voltage was 2.1. You'll notice the reading here says 4.24, but that's because I'm actually going across two gaps. So whatever this voltage is divided by 2, and that's what my gap voltage is. So this would be 2.12 as my gap voltage. My cell voltage is 8.44, and the thing that what I thought was most interesting is that I can pretty much control the efficiency of this cell. I can make it as efficient or inefficient as I want just by turning this one pot right here. Trying to watch the camera and watch the so if I crank this in, whoa, don't come off the table. I crank this in and crank my plate voltage up, and you watch my output start to crank up. My plate voltage, here's my 2.2 is the one I always liked, but I mean if I go to like 2.5, which would be 5 volts here, fell off of it. Enough hands. Enough hands. I'm not going to do math on the fly. I'm just going to 5 volts on this one right here, so that'd be 2.5. So that's 2.5. That would be 2.5 gap voltage. Notice my output is really going now. My cell voltage is 10 volts, and my amps have cranked up to the 20.65. Now, in this configuration, with it set like this, it'll heat up. So I don't want to leave it like this for very long. But I mean, it sounds to me like, the way I'm looking at it, so I can dial in whatever efficiency I want electronically, as opposed to having to worry about mixing my plates or worrying about the concentration of the electrolyte. I can make it as efficient or inefficient as I want. If I wanted to, I could just crank this all the way up and it'd start cranking out heat. But I mean, right now I don't have my thermometer out, but it feels like maybe 85 degrees. No, maybe not even that much. I just think that's sweet. I think that is sweet. I mean, that's cool. I mean, I'm thinking I could probably wire all of these plates if I wanted to. Just go plus minus, plus minus, plus minus, and get the efficiency I want out of it. That'd be well, that's a lot more wiring than this. Like I said, I'm just playing with it. I'm trying to decide. I mean, I got to do some gas measurements to find out if it really is as efficient as I claim it is. I'm not prepared to do that right yet. Like I said, I'm just now playing with it. So, all right, that's all I got on this pass. Basically, I've come to understand. Previously in the test, I was using the current limiting to set the cell voltage, and that was in error. The current limiting is what your top end, what the maximum amount of current you want to allow to pass. So once this gets to 22 volt, or once it gets to 22 amps, it starts folding back even further and starts dropping these voltages here on my cell and on my plates to reduce the amp current. So this is sort of like the current limiting is the safety net, but the percent duty is how you actually control how efficient your cell is going to be. All right. Well, like I said, I think I've wasted enough of your time. This is Luther P40 signing off. Thank you very much for taking the time to watch my videos. Take care.